Right, let's try another one. So let me try one over here. So let's call this part B. So if A is given by 2, 0, minus 3, so that's the coordinates of A, and if B has coordinates 1, 4, minus 1, and if C has coordinates 2, minus 1, 0, so let's work out the equation of plane formed by these points. So in step number 1, so let's remind ourselves. So first let's convert them as position vectors in order to work out AB and AC. Okay, so here goes. So OA, the position vector of A relative to the origin. So from point to vector, it's going to be 2i, okay, plus 0j minus 3k. Similarly, OB, so from point 1, 4, minus 1 to a vector, 1i plus 4j minus k. And finally, OC, from point 2, minus 1, 0 to a vector, 2i minus j plus 0k. So 2i minus j. Okay? So let's firstly work out AB. So remember the quick idea. It's O of the second letter, so second letter is B, minus O of the first letter being A. So if we substitute the vectors in, OB is I plus 4j minus k, minus the vector OA, which is 2i minus 3k. So in this case, if I add the like components, I minus 2i is minus I. Okay, I only have one j component, 4j, and adding the k components, minus k minus minus 3k is plus 2k. So that is the vector AB. Let's work out the vector AC. So AC is O of the second letter, which is C, minus O of the first letter being A. So OC we know, 2i minus j, minus vector OA we know also, so that is 2i minus 3k. Okay, so once again, if we add the like components, 2i minus 2i is nothing. Okay, I only have one j component, so minus j, and I also have one k component, so minus of minus 3k plus 3k. Okay, so that is the vector AC. So let's go back to the previous example. So now that we have AB and AC, let's work out the normal vector n. N is AB cross AC, and let's do that calculation using the determinant of a 3x3 matrix. So here goes. So normal vector n, that is AB cross AC. So that's going to be the determinant of a 3x3 matrix. The first row is I, J and K, the unit vectors I, J and K, as always. Second row are the coefficients of I, J and K in AB, which are minus 1, 4 and 2. So minus 1, 4 and 2. And the third row are the coefficients of I, J and K in AC. So I have no I components, so 0. Coefficient of J, minus 1. Coefficient of K, 3. Okay. So when we expand a 3 by 3 determinant, I normally expand using the first row. So the signs associated are plus, minus and plus. So when I expand using the first row, it's plus I multiplied by a 2 by 2 determinant. So remember, to get the elements of the 2 by 2, just cross out the row and column associated with that first element I. So we're going to have 4, 2, minus 1, 3. So 4, 2, minus 1, 3. Those are the elements of that determinant. Minus j, so minus j, multiplied by another 2 by 2 determinant. So cross out the row and column associated with j, and the elements in this determinant should be minus 1, 2, 0, 3. Okay, plus k, so plus k, multiplied by, cross out the row and column associated with k, and the elements of that determinant are minus 1, 4, 0, minus 1. Okay, so when we expand further the 2 by 2 determinants, so remember, multiply the elements along this diagonal, the leading diagonal, then subtract, then multiply the elements along the lateral green diagonal. So multiply the elements along the red diagonals, then subtract, then multiply the elements along the green, what we call lateral diagonals. So here goes. I multiplied by 4 times 3 is 12, minus, and 2 times minus 1 is minus 2, with this minus is plus 2. Okay, so just be careful. Minus j, open a bracket, minus 1 times 3, minus 3, minus 2 times 0, 0, plus k, open a bracket, minus 1 times minus 1, 1, minus, then multiply the elements along the opposing diagonal, 4 times 0, 0. Okay, so what is our normal vector? So let's simplify. 12 plus 2 is 14, so 14i. Minus 3 minus 0 is minus 3, times minus j is plus 3j. And 1 minus 0 is 1, times k, 1k. Okay, so that is your normal vector for the plane, 14i plus 3j plus k. Okay, that completes step number 1. And remember, in the previous example, step number 2 is to work out capital P, that being a dot n. And remember, A is a fixed point on your plane, and A is your choice because you've got 3 fixed points on your plane. Okay, so let me continue on the reverse page. So in step number 2, P is a dot n. So for A, I'm going to take the vector OA. So the vector OA is 2i minus 3k, but you can just as well take OB or OC because all of these points are fixed points on your plane. Okay, so OA, I'm taking 2i minus 3k. So 2i minus 3k, and the vector n, so 14i plus 3j plus k. Now, when you take the dot product, so when you multiply the coefficients of I, 2 into 14 gives you 28, okay? Plus, you have no j component here, so 0 times plus 3 is 0. Plus, when we multiply the k components, minus 3 times 1 is minus 3, okay? So if you simplify further, 28 minus 3 is 25. So that is the value of P, the scalar, that's 25. Okay. And remember, step number 3, so if I refer to the previous example, step number 3 is substitute your data into the scalar product equation of the plane. Okay, so let's do that. So here's step number 3, equation of the plane, formula being r dot n, that is equal to capital P. So when we substitute what we know, the normal vector n, that is 14i plus 3j plus k, so 14i plus 3j plus k, and that is equal to the scalar p, which we found in step 2, that's 25. Okay, so that completes this example, and again, that is the method in order to work out the equation of a plane containing, or which is formed by 3 points. Okay, so that also ends this video. So I hope you found this video helpful. Do related practice questions, and I hope to see you in the next video. Thank you.